Hello everyone. I guess I'm audible. So today I'm Shaurya here, and today I'm going to present a seminar on IoT-based automobile anti-theft system using the Bolt Wi-Fi module. So this is a security system for automobiles, which has been made in such a way that when the thief tries to break into the vehicle, it sends an alert to the user of the vehicle. So let's proceed with this. So today's course of action is as follows. First is the purpose of this project, which is followed by the hardware requirements of the system, then the software requirements of the system, the hardware setup of the system, followed by the software programming of the system, and finally, the working of the system. At the very end of the seminar, there will be ample time given to you to pose your questions. So it is a request to you that please keep all the questions for the very end. So let's move on. First is the purpose of this project. So the main purpose of this project is to provide the user a solution to track their vehicle in real time. Suppose someone has stolen your vehicle. Now, this system allows you to track the location of the vehicle in real time, and it can give you the location of the vehicle no matter where in the globe it is positioned. The system sends alerts to the owner of the vehicle on Telegram. So it uses the Telegram app for the notification system. So it sends alerts to the owner of the vehicle on the Telegram in the form of a message. The message contains a Google Map link, and in the Google Map link, the latitude and longitude coordinates are given. So when you click on the Google Map link, you can find the position of your vehicle in the Google Maps. Apart from this, a buzzer system is also provided. So the purpose of the buzzer system is to alert the people nearby the car that the car is being stolen. Let's proceed. So this is what the system looks like. This is a breadboard, as you can see. This is a laser module, an LDR module. LDR module is a light dependent resistor module. So this is an LDR module. This is the GPS module. This is the Arduino board, and there is a Bolt Wi-Fi module as well. It's not here in the picture. I'll show it to you gradually. The hardware requirements of the system. Okay. So the first and foremost thing which we require is an Arduino Uno board and also a Bolt IoT Wi-Fi module. We can use an Arduino mini board as well, but since I had an Arduino Uno board at my home, so I used the Arduino Uno board. After that, the Bolt Wi-Fi module, a breadboard. I have used a large generic breadboard so that I could place all of the components properly. A number of male-to-male jumper wires, a number of male-to-female jumper wires, a buzzer, 330 ohm resistors, a status LED. Now this can be of any color. I have used a blue LED, so you can use a red one or green one as you deem convenient. The next one is the KY008 laser module. Now the module looks something like this. It has 3 pins. One is negative, one is positive, and one is signal. So we will use only the negative and the signal pins. The hardware setup will be discussed later. So this is the KY008 laser module. Then we have used an LM393 photoresistor module. So most of you would know what an LDR is. An LDR is a light dependent resistor which actually changes its voltage on the basis of the light amount of light falling on. So I have used a module. What is the difference between a module, LDR module, and just an LDR? The LDR module, which is the LM393 module, it consists of a trim pot. So this blue part which you can see is a trim pot. A trim pot can be used to adjust the sensitivity of the LDR to the light. Next, we have used the Neo 6N GPS module, and obviously a USB A to USB B cable for powering up the Arduino, and a USB A to mini USB cable for the Bolt Wi-Fi module. The software requirements of the system. Okay, so the first thing which we require is the Bolt cloud. The Bolt cloud is required because in this system, there is an option, rather there is a page which has been created for the user to enable or disable the system through his mobile phone. So in order to create that page, we need the Bolt cloud, so that we can create a product and link it to our Bolt device. We need the Bolt cloud. Apart from that, we need the Bolt IoT Android app. The Bolt IoT Android app is required to build the page for the mobile phone, so that you can control the system. Okay. Next is the Arduino IDE. This will be required for programming the Arduino board. Next is the Telegram system. The Telegram system will be used to receive notifications from the security system. Okay. The next three set of things, that is the Oracle VM VirtualBox, Ubuntu Server, and Python 3.8. I have used Oracle VM VirtualBox with Ubuntu Server installed on it and Python 3.8. But some of you may be working with the DigitalOcean Droplet, which is actually a cloud server with Ubuntu installed on it. So you can use that as well. But I have used Oracle VM VirtualBox with Ubuntu Server and Python 3.8. Let's proceed. Now the hardware setup of the system. This is how the hardware setup looks like. I will discuss this in detail. Just see the overview of the system. This is the Arduino board. This is the Neo 6N GPS module. This is the Bolt IoT Wi-Fi module. This is the breadboard. This is the KY008 laser module. This is the LM393 photoresistor or LDR module. This is the status LED. The status LED will be used to determine whether the system is active or inactive, or enabled or disabled. This is the buzzer. So let's go on to the details. Okay. So firstly, the most obvious connections have to be made, which is the ground and power supply. So pull a connection from the 3.3 volt of the Arduino board to one of the columns of the breadboard. So this is the connection marked by the red one. This red connection goes to the first column of the breadboard. So this is a complete 3.3 volt connection. The next is a 5 volt connection to the next column of the breadboard, which is marked by this purple line. So the second column of the breadboard is a 5 volt connection. On the opposite side of an opposite set of columns, connect the ground to one of the columns. So this black line shows the ground. This is the ground connection. So this entire line is grounded. Okay. Now let's go to the connection of the LED on the breadboard. The positive leg of the LED, which is this one, goes through the 330 ohm resistor to the pin D5 of the Arduino. So this green wire goes to the pin D5 or data 5 line of the Arduino. And the negative one goes to the ground as usual. The buzzer. The negative leg goes to the ground and the positive leg goes to the data 4 pin of the Arduino. Okay. Next is the LM393 module, which is this one. The positive terminal will go to the 3.3 volt. So its operating voltage is 3.3 volt. Do not try to put 5 volt on this LM393 module. Otherwise, it may simply short circuit. So the positive terminal goes to the 3.3 volt. Negative terminal goes to the ground. Now the A0 pin. What is the A0 pin? A0 pin is actually an analog to digital converter. So it reads data through the LDR and transmits data through this A0 pin, which is actually an analog to digital converter. It reads data in analog form and transmits it in digital form. So this A0 pin will be connected to the A0 pin of the Arduino. This one, the brown line. Next, now the laser module. Now you have to place the laser module in such a way. This is the laser emitting part of the module. You have to place it in such a way that the laser falls directly on the LDR. The reason for it will be discussed later. So the usual setup of the system will be that the laser will always be falling on the LDR. So if this is the LDR module and this is the laser module, the laser emitting part should face the LDR. So the laser module faces LDR of the LM393 module on the breadboard. Negative terminal as usual goes to ground, and the signal pin, not the positive pin, the signal pin goes to 5 volt. Now, since we require a continuous emission of a laser, we will use the signal pin. The signal pin is that pin when you connect any pin to it. If it's 0, the signal pin will emit 0. If it's 1, the signal pin will emit 1. So if we connect it to the 5 volt supply, it's always 1. So it gives us a continuous emission of laser. Okay. Next is the data 0 pin of the bolt module goes to the data 2 pin of the Arduino. So here the data 0 pin goes to the data 2 pin, this brown one. So the purpose of this pin is to to let the Arduino board know whether the user has enabled the system or disabled the system. Now, when the user enables or disables the system, the command is sent through the mobile app to the Bolt Wi-Fi module. Now, the Bolt Wi-Fi module has to transmit this data to the Arduino module. So this D0 pin of the Bolt module transmits this data to the data 2 pin of the Arduino module. Okay, so this we will call this pin the enable pin or the disable pin. Okay, next, the transmit pin of the Bolt module goes to a D0 pin of the Arduino. So the transmit goes to the D0 of the Arduino, which is the receive pin for the Arduino board, and the receive pin of the board goes to a transmit pin of the Arduino. So it's a cross connection, transmit to receive and receive to transmit. Okay. Next, the GPS module, which is this one. The VCC as usual goes to 3.3 volt, so its operating voltage is 3.3 volt. Ground goes to ground pin. I've connected this to the bolt module because pins were available on it for the ground and 3.3 volt connection. Okay. Next, transmit goes to the D7 of Arduino. So basically, the Neo GPS module is communicating with the Arduino board through the 7 and 8 pin. So transmit goes to D7 of Arduino and receive goes to D8 of Arduino, these two lines. Okay. Lastly, you have to power the Arduino and the Bolt module. So the Bolt module is connected to the power supply through the USB A to mini USB cable, and then Arduino is connected to the power supply using USB A to USB B cable. Next, the software programming of the system. Now, the software programming of the system consists of many different parts. So the first part of it is setting up the telegram to receive the notification. So most of you already know how to set up a telegram app to receive notifications through a bot and a channel. But since there may be many people who do not know, so I'll discuss this in brief. So what is a channel? A channel is basically similar to something like a WhatsApp group. So it's analogous to a WhatsApp group. So in order to create a channel, first we have to create a channel to receive the notification. So basically it's like a group where we will receive the notification. So in order to create the channel, open the Telegram app, and on the bottom right corner, there will be a pencil icon, pencil shaped icon. Just click on it. It's the new message icon. So just click on it. It will open the new message screen. And from that screen, click on new channel. Now, it's very obvious. We have to type a name for the channel. So type a suitable name for the channel, and you can also upload an image. It's optional. You can upload also. You cannot. You may not upload. So it's just like a WhatsApp group icon. You may upload an icon. You may not upload an icon. fill in the description for the channel, what the channel is supposed to do. And there is a tick mark on the top right corner of the page. So just click on the tick mark. So it confirms your settings. Next page which pops up is the channel setting page. So this page, this channel, it has to be a public channel in order to communicate with the channel. So set the channel to public and type in a permanent link for the public channel. A permanent link has to be typed for the public channel so that we can refer to the channel using the link. So when you are typing the name for the when you're typing the permanent link for the public channel, make sure that there is no space in its name. So type a permanent link for the channel and again click on the tick mark at top right corner to confirm your settings. Okay, next. The next screen is an add subscriber screen. Now, naturally, the user is a subscriber. So at this moment, we would not do anything with the add subscriber screen. We will just proceed to the next page. So on proceeding to the next page, the channel creation is successful. Okay. In order to receive notifications in the Telegram channel, we need a bot. So what is a bot? Bot is like a chat bot. We all have encountered chatbots. So it's like a chatbot. So we need to create a bot so that it can control the notifications in the channel. So on the search icon in the Telegram, just search for the word bot father. BOTFATHER, bot father. Bot father is actually a master which can be used to create new bots. Now this bot father, there will be a tick icon or a blue tick icon just beside the name bot father. That is the proper bot father search result we are looking for. So once you get that, just click on it. It will open the bot father chat screen for you. Now, in order to start the process of creating a new bot, just write /start and click on send. It's a chat screen, so just type /start and click on send. Now, after doing this, the bot father will give you a list of commands which can be used to control bots. So what do we want to do? We want to create a new bot. So just type on the chat screen /new bot and again click on send. When we do this, the bot father asks us for a name, for a suitable name for the bot. So decide on a suitable name, any name will do, and just click on send. When we send this, the bot father next asks us to enter a username for the bot. Now the username for the bot has to follow a specific set of protocols. The protocol is that whatever name you username you allot for the bot, just make sure the word bot must follow that. Suppose we are concerned with receiving temperature notifications from the bot, so we can name the bot temperature bot. So the bot word must be there at the end. So just type temperature bot or whatever you want and just click on send. If the username is taken, then you will have to rename it again. So write the appropriate name and click on send. So on successful bot creation, you will get a message from bot father stating that the bot creation is successful, and you will be given two important things. Please note them down and do not lose them. They are the HTTP API token for the bot and the link for the bot. These two are required to communicate with the bot. So do not lose them. Keep them with you and note them down. Now, as the bot has been created, we have to add it as a subscriber to a channel. Only then can it communicate with the channel. So let's go on with that process. From the home screen of Telegram, so just when you open Telegram, you will just see the channel which you have created. You will see the channel name. So it's like the group name of a WhatsApp group. So just click on it. The chat screen for the channel will appear. Click on the name of the channel at the very top. When you click on the name of the channel, this will open the description page for the channel. And there will be a members tab in this page. So just look for the members tab, and on the members tab there will be a subscribers button. Just click on the subscribers button. So when you click on the subscribers button, you will be able to see that the user is naturally a subscriber to the channel. So we need to add the bot. So click on add subscribers. You will get a provision for searching for the username of the bot, search for the username of your created bot, and click on the appropriate result. When you click on the appropriate result, the system tells you that bots can only be added as administrators or admins. So just click on make admin. So you are basically making the bot an admin of the channel so that they can control whatever happens with the channel. Okay. So on the next page, which is the admin rights page, you have to tell the bot what it can do and what it cannot do. So it is supposed to send us notifications. So basically it will post messages on the channel. So on the admin rights screen, just click on post messages. If it's not already done, just click on it. And to confirm your settings, click on the top right tick, click on the tick mark on the top right corner. So the bot gets successfully added to the channel. So this whole process ends the setup of the Telegram to receive your notifications. Okay. Next is the software programming of the system regarding the setting up of the server side. So there has to be a server side code in order to run the bot, in order to control the bot, in order to send messages to the bot to the Telegram channel. So let's do that. So for a bot to send notifications to a channel, we need to send HTTP requests to it via a program. So this program needs to run on the server side. You can do that through DigitalOcean Droplets, Ubuntu server on DigitalOcean Droplets, or you can do that through Oracle VM VirtualBox as well, with Ubuntu server running on it. Now, since I have used VirtualBox, I'll be talking about that. Power up the Ubuntu server on the VirtualBox, and you can create a directory for your project. So you can suppose this is the car anti-theft, so you can create a directory called anti-theft. So just create a directory for the project, enter the directory, and you need to create a configuration file. So this configuration file will contain certain necessary information which is required to communicate with the Bolt module, the channel, the Telegram channel, as well as the bot. This must be a Python file. So just save the file with a .py extension, which is .python extension. I have named mine as carconf.py, which is car configuration.py. You can name yours accordingly. So it looks something like this. It will contain your Bolt module's API key, which you will get in the Bolt Cloud page of your device. It will contain your device ID, Bolt device ID. Every Bolt device comes with a specific device ID. So you will get the device ID over there. Okay. Next is the Telegram chat ID. The channel you just created, you had to put a certain name to it or a permanent link to it. So that is the Telegram channel chat ID. So you have to put the Telegram channel chat ID in the configuration. Okay. Next is the Telegram bot ID. You just created a bot and you got a message on Telegram giving you an HTTP API token as well as a bot link. So that bot link is actually the bot ID. So you have to type that in this way: bot space, bot followed by the bot link over there. Bot with the link following. Next is the map URL. Now, what is map URL? In order to search for certain latitude and longitude information on Google Maps, you can directly type in this URL with the latitude and longitude on the address bar, and you will get that location. So in order to send this as a message to our Telegram bot, we have to store the URL this way. Then we have to concatenate it with the latitude and longitude information and send it to the bot. So these all will be contained in the configuration file. Okay. Now comes the main code of the server. Now let me give you an overview of what the code does. The main code will scan strings which is being sent from the Arduino to the Bolt module by the serial port. What is the serial port? Is the receive and transmit pins which forms the serial port. It does a serial communication, so it's the serial port. So the main code will scan strings, which is being sent from the Arduino to the bolt module via the serial port. Now, where are these strings coming from? These strings are basically coming from the GPS module, which has been attached to the Arduino. These strings are basically latitude and longitude coordinates. So these strings will be sent from the Arduino to the bolt module. These strings have to pass through certain validation checks. I will discuss the validation checks when I'll discuss the program. So just know that the strings have to pass through certain validation checks. On passing the checks, the strings can be considered latitude or longitude of a location. On passing the check successfully, it means that the information which we have got is actually the latitude of a place or a longitude of a place. So this latitude and longitude information are sent every 1 second. So basically latitude and longitude information, first the latitude is sent, then it takes a gap of 1 second in the Arduino code, then again it sends the longitude, and again it takes a gap of 1 second, and this follows. So it's sent every 1 second. So the string which is received first is the latitude, the next one is the longitude. So this is how it's sent. The process is fixed. So first the latitude, then the longitude. So we can make out that when the string which is received at an odd interval is the latitude, and the one which is sent at an even interval is the longitude. So when we receive a pair of latitude and longitude values, we just concatenate that with the map URL and put it in a message. This message is actually the Google Maps link to the location where our car is positioned on the globe. And this is sent as an HTTP request to the created bot. So we have to tell the bot that it has to send this message to the group. So it is sent as an HTTP request. Okay. So the main code is also a Python file. Mine, I have named it as gps.py. You can name yours accordingly. So let's come to the code. Okay. So first line says from Bolt IoT import board. So what is Bolt IoT? Bolt IoT is actually a library which is used to communicate with the Bolt Wi-Fi module. It's a Python library. So from the library Bolt IoT, we are importing Bolt. We are also importing the time JSON carconf we just created. That is the configuration file, and the request modules. Okay. Next, ignore coord. Now just note this ignore coord is a flag variable. It has a certain purpose. The purpose is that whenever data is being transmitted from the Arduino to the Bolt module, sometimes due to transmission errors, the latitude may break up into two parts. Suppose latitude is 39.05049, for example. It tends to break up into two parts due to transmission errors. The first part may be 35.05, the next part may be 049. So this ignore coord is used to indicate whether we are receiving a complete latitude and longitude or we are receiving two different parts. So if ignore coord is 0, it means the latitude or longitude values are okay, so we can use them. If it's 1 or 2, it means that it is actually transmitting two broken parts. The first broken part and the second broken part. So for that purpose, I have used values of 1 and 2. And in order to indicate a proper latitude or longitude value, it is indicated by ignore coord equals to 0. So firstly, we'll set ignore coord equals to 0. X. Now what is X? X has been set to 1. X is a flag variable which will determine or which will tell us whether the information we are receiving is a longitudinal value or latitudinal value. Basically, it counts between odd and even. So when it's odd, we are receiving latitude value. When it's even, we are receiving longitudinal value. Okay. Then we create a variable called myBolt. This line myBolt. So myBolt is what is it doing? It is actually communicating with our Bolt module using its device ID and API key. So it sets up the communication, and the next line, which is R equal to myBolt.serial begin. It begins communication, serial communication with the Bolt Wi-Fi module at a baud rate of 9600. So this 9600 is actually the baud rate or communication rate. Okay. Next is a while loop. So this whatever is inside this while loop, this will go on for an infinite amount of time. So I've given while true. So there may be certain errors while doing the transmission, which may not be in our control. So in order to handle those exceptions, we have used a try block. Try. Inside the try block, what are we doing? We are just reading the information we are getting through the serial ports of the Arduino to the board. So we are just reading it. My bolt.serial read. 10 means it reads 10 places. So my bolt.serial read. So R1 will contain whatever information has been sent from Arduino to the bolt module. Okay. The next line is data equals to JSON.loads R1. So you must be, most of you must be familiar with what JSON is. You have to convert the information which you are getting into JSON form. So in order to read that, you have to convert it into JSON form. Okay, so we are converting the information which we have retrieved to JSON form, and we are storing it inside data. Okay, now the next step is the valid set of validation checks I was talking about. Now you may encounter certain values which are not latitude or longitude, so we have to omit that. So these set of values may be, it may be 0. Okay, so this data variable, inside the data variable there is a field called value. This is the variable, value is the field. The value field contains whatever information we have just retrieved. Okay, so this data value field cannot be 0, it must be greater than 0, the length of the field. Okay, so a length of 0 means you have got nothing, you have not got any string, so its length must be greater than 0. Okay, sometimes it so happens that you do not receive any value, just receive the message called command timed out. So the data value field must not include command timed out. So data value of find command timed out equal to -1. So the data value must not be command timed out. And also data value must not be just an empty space. So these are the validation checks which the strings must go through. Okay, next step. If it passes these set of validation checks, it goes on to the next validation check, which is ignore quad equals to 0. As I told you earlier, if ignore quad is 0, we can proceed with the transmission. If ignore quad is not 0, we cannot proceed with the transmission. So let's consider the case where ignore quad is 0. That means we can proceed with the transmission. So the next validation check. Now, when a latitude or longitude value is retrieved, it must be a set of 7 digits. So if greater than 7 or 7, minimum 7. So if it's less than 7, it means it has been broken up into 2 parts. As I told you, due to a transmission error, the string may be broken up into 2 parts. So if it's greater than or equal to 7, that means the string is okay. We can proceed with the transmission. Now, if x equal to 1, if x equal to 1 means we have received the latitude value. So we just, what happens when we receive x equal to 1, we just increment x. We increment the value of x, because next time x has to be 2 when we receive the longitudinal value. X cannot be 1 again. So we increment it to x equal to 2. We just print the latitude value. I have printed this for testing purposes so that I can make sure that I'm getting the right value. So you may not print this also. And you will have to store the latitude value in a lat variable. This is the part for the latitude value. Okay. Next, if x is not 1, then x is 2. So the else portion accounts for it. If x is 2, that means the next transmission should, this is the current transmission is a longitude value if x equals to 2. So the next transmission must be a latitude value. For that, x has to be 1. So I set the flag x equal to 1 again for the next transmission. Okay. Then the longitude value is just printed. This is for testing purposes again. The longitude value is stored in a variable called lon. And I concatenate both the lat and lon with a comma in between in a coord variable. Since I've received a pair of values, I can use these values now. So I concatenate into a coord variable. Okay, next. Now the URL. What is the URL? This URL will be used to communicate with Telegram. So it's basically a Telegram URL, https api.telegram.org, the Telegram bot ID with the send message. So it's basically telling Telegram to send a message to the bot with this ID, which we stored in the car configuration file. Now, what will the message contain? Your car is being stolen. Current location of car is as follows. So what is the current location of car? Remember, we used a map URL in the car configuration file. So it's appending the car conf.map URL at the end with the variable coord. We use the coord variable here to uh, concatenate the latitude and longitude values. So it's basically appending it at the end of the map URL. So it becomes a complete Google Maps URL which can be used to track the car. Now, it is storing this in a JSON format. This is the JSON format. Chat ID, there should be an attribute and a value. So the attribute is a chat ID, value is the Telegram chat ID, which we have just created. And the text should be what? The text should be a message. The message is here. This is the message. Now, any type of transmission must be done in a try block because we do not know what kind of exceptions we may encounter. So inside a try block, we are sending a request, requests.request. What do we have to do? We have to post the request. We are posting the request with this URL here, and the parameters will be this data, this JSON data, which is the chat ID and the message. So this is the entire format. We are posting it to this URL, which is the api.telegram.org with the Telegram bot ID and send message. And the parameter is the data. What is the data? Data is telling us the chat ID where the bot has to post the message and what message it has to post. So this is the complete format. And there will be an exception part as well. So if it encounters an exception, it prints the exception. Okay. Now going back to the previous page, we have solved this part. So coming to this outer if layer. Now I told you that every latitude or longitude values, the length must be greater than or equal to 7. If it's not greater than or equal to 7, that means it's less than 7, which means the data has been broken up into two parts. So we cannot use the broken up data. So the data, instead of arriving in one single transmission, it will arrive in two different transmissions. So basically what we have to do is we cannot use that. We have to ignore two transmissions. So what we will do is we will set ignore coord to 2. If the length is less than 7, we will set ignore coord to 2. So when ignore coord is 2, what will happen next time when the loop runs for the next iteration, it will try to check if ignore coord is 0. So this time it will find ignore coord is 2. So if ignore coord is not 0 and it's 2, that means we cannot proceed with the transmission. We will just ignore the transmission. We will just reduce its value by 1. Why are we reducing its value by 1? Because the broken up pieces of latitude and longitude come in two parts. We have to ignore the first part. We have to ignore the second part. Then we can go on with the next transmission. So 2. So 2 will be reduced to 1. 1 will be reduced to 0. When it gets reduced to 0, again you can proceed with the transmission. Now again it has to go to the validation checks. That is a different matter. But when it gets reduced to 0, we can go on with the transmission. Okay. And lastly, the outer try block, you have to print the exception for it. Except exception is E. Okay. Next part. Software programming of the system. Okay, now we have to set up the bold cloud size so that we can create a page for our mobile phone, so that we can control the system, enable it or disable it through our mobile. Okay. So this is how the page will look for your mobile phone. It will contain an enable button and a disable button. On clicking on the enable button, it will enable the security. On clicking on the disable button, it will turn the security off. So this will be indicated by the status LED which we have put on our hardware. The status LED will let us know when we click on enable, the status LED will glow. When we click on disable, the status LED will not glow. So in order to do this, you must have a Bolt Cloud account. In addition to the Bolt module, you must have a Bolt Cloud account. And preferably, you must have a subscription to Bolt Cloud Pro. This is because since continuous transmissions are being made to the Bolt product using the Python code, if you do not have a Bolt Cloud Pro account, using the normal Bolt Cloud account, you are limited to only a certain number of interactions. But with the Bolt Cloud Pro subscription, the number of interactions is unlimited. So just opt for the Bolt Cloud Pro, go to your cloud account and click on products. You can see products on the left hand side, click on products. So here you can basically see all the products you have created, and you can get an option to create a new product. So suppose I'll teach you how to create a new product. So click on add product. After we click on add product, we get this page. This is the build product page. On the build product page, just put the name of the product which you want to, set it as an input or output device, and just tell it how you want to collect the data. It's GPIO or UART. And you can optionally upload a icon for it. And after you're done, just click on this done button. So I'll show you mine, how it looks. This is how my product page looks. The name is car anti-theft. I have put an icon for it. Now, why is it an output device and not an input device? We will use our Bolt products page in our phone to control an LED. So we are just sending an output command. So this should be an output device, not an input device. We are not receiving anything, we are sending. So it's an output device. And the data collection method should be GPIO, which is general purpose input out. Once you're done, just click on done. So the next page will be something like this. When you are done, what you have to do is, let's go back to the first build products page. When you're done, you will see that your product has been added here. It's car anti-theft written over here. Okay, now you will find the configure icon. This is the configure icon. Let's go to the next page. This is the configure icon. When you click on it, you will notice a page opening up like this. So this is where you can configure your hardware. You can configure your product. So what we have to do is, you must remember that when we were setting up the hardware, we used an enable pin from the Bolt Wi-Fi module to the RD. So that was the 0th pin here. So just rename it as enable. You can rename it anything you want. I have renamed it as enable. And then click on this save icon. Just rename it as enable. Click on the save icon, and then go to code. You have to code your page. It should look a certain way. It should contain the enable and disable buttons, so it should look a certain way. For that, we have to put the code in. So go to the code part. It's written over here, code. Okay. When you click on code, this page opens up. This is the coding page. First and foremost thing which you have to do is put a file name for it. I put anti-theft as the file name, and put an extension. JS means JavaScript. So anti-theft is a JavaScript with a JavaScript extension. The file should be a JavaScript file. So antitheft.js. So JS is the extension. And what is the code? I'll show you the code. This is the code. We are creating two buttons. The first is a button named enable. Action will be, what is the action of the button? When you click on it, what will it do? It will actually write the 0th pin. The 0th pin is a digital pin, so it will perform a digital write on the 0th pin. Now I'll tell you something. Just remember this for the next set of slides. Once we click on the enable pin, it will result in a low value. Normally, what do? When we switch something on, we associate it with a high value. But here we have associated it with a low value. I'll tell you the reason later. Just remember that when you click on enable, it's low. When you click on disable, it's high. So first button will digital write low, and second button, which is the disable button, it will digital write high. So enable is low, disable is high. Just the opposite. Okay, next page. Now, when you're done, when you have saved everything, you have to link the product with your Bolt Wi-Fi module. So you remember seeing these set of icons on the products page. So first we clicked on configure. Now we will click on link. This is the link icon underlined in red. When you click on the link icon, this page appears. This is the linking page. You will, if you have multiple Bolt devices, you will be able to see multiple Bolt devices listed here. Since I had one, uh, the one is listed here. So just click on it to link the Bolt device to your product and click on done. Once you click on done, the entire process is over. So this was the Bolt cloud site for the mobile page. Now the Arduino. This is the last programming part. You have to program the Arduino. For the Arduino, we have used certain header files. These will be available in the GitHub. Now, why have we used these header files? We have to communicate with our Bolt using the Arduino. So we have used two header files, bolt device credentials.h and bolt IoT Arduino helper.h. So these two files will be available on GitHub. You can download them anytime. Okay. Now, since I told you, and most of you know, the Arduino, on the Arduino, the 0th and first pin correspond to the receive pin and the transmit pin. So these are used for serial communication. These are already hardware provided. Now, apart from that, if you have any other device you want to attach to the Arduino for serial communication, you have to convert other pins to serial communication pins. That can be done through software. So that is called software serial. So that is software serial communication. That is not hardware serial communication. So for that purpose, there are many libraries. One is the software serial library. One is the Neo SW serial. SW means software. So Neo software serial library. One is the software serial library. So we will have to change all instances of the software serial library to Neo software serial library. Why? Because this new software serial library and software serial library clash with each other. They do not work well with each other. They clash. We could have also used software serial, but Neo SW serial will be required by us later also. So we will just change all the instances of software serial to Neo SW serial, and we will rename the file to Bolt IoT renew helper.h. This is what I have renamed to. You can rename it to anything you want, as long as you remember the name. So the header file is renamed to Bolt IoT renew helper.h. Okay. Apart from this, we have used two more libraries. One is the NMEA GPS.h. This is used to control the Neo GPS module. String.h library for string purposes. And the Neo software serial library. Again, the Neo software serial library will be used to retrieve the latitude and longitude information from the NMEA GPS or the Neo GPS module. Okay. One more header file, which is the Bolt device credentials. So your Bolt device has got an API key and a device ID. So what you can do is you can include those in the Bolt device credentials.h and you can rename it to something else. Why you should do this? Because see, this is the Bolt device credentials.h. This is how it looks. So I have just included my Bolt device ID and API key over here. If you do not do this, every time you create a program for your Bolt device, you will have to type them in the program itself. But if you write it down in a header file, you can just import the header file and you'll get the information. So it's better to type it once and reuse it. So reusability of code is better. So just typing it out would be a good option. So just type it out in the Bolt device credentials.h and rename it. Okay. Coming to the next set of code. This is the main code. Okay. first what we are doing is we are including all the required header files over here. All the required header files have been included over here. Next, if you remember when I was discussing the hardware part, the GPS module has been uh, attached to the 7th and 8th pins of the Arduino. So receive pin is 7, transmit pin is 8. So we have set that accordingly. Okay. Now we are creating an instance of the Neo software serial. So we are making the receive and transmit pin, which is the 7th and 8th pin, software serial pins. So Neo SW serial GPS port. GPS port means that is we are using that for GPS purposes. So the variable name or instance name is GPS port. So GPS port, RX pin, TX pin. RX pin is 7, TX pin is 8. Okay. We are defining a baud rate of 9600, which we will use in every place for all the communication. The baud rate in all the devices must be the same for communication. So this is a static constant 9600. Okay. For retrieving data from the GPS module, we need to create an instance of the NMEA GPS library, which is here, GPS. An instance of the NMEA GPS library is GPS. Okay. What is GPS fix? GPS fix is used to retrieve the data from the variable GPS. GPS is an instance of NMEA GPS. In order to retrieve the data from it, you need a data type called GPS fix. These are all mentioned in the NMEA GPS library. When you download it, you will get the documentation with it. You can read it. So GPS fix is the data type required to retrieve the proper coordinates from the NMEA GPS library. Okay. Now fix count. What is fix count? One thing I haven't told you is that when the notifications, suppose your car is stolen and the notifications are being sent to your Telegram, so it's not required to send the notifications every millisecond or every second. It can be done every 5 seconds or every 10 seconds. So I have chosen an interval of 10 seconds. So this fixed count will count 10 seconds for me. So this fixed count is a counting variable. Okay, apart from that, we have used a buzzer on pin 4, enable on the enable line, which is on pin 2. Okay, the status LED or the enable LED, which is on pin 5, string X we'll see later, and stolen. What is stolen? Stolen tells us the status of the car. If stolen is 1, that means the car has been stolen. If stolen is 0, the car hasn't been stolen. Okay. Okay, the next line USW serial SCR 1112. This was for testing purposes. So this we don't need this. This was for testing purposes. So okay, the setup part now. So go to the VoIP setup part. We will begin all communications with the 9600 baud rate. So there is if you know how to code in Arduino, you will know that there is a serial monitor where you can see all the outputs from your sensors. So that is called the serial monitor. So you will begin communication with it at 9600 baud rate. Okay. Begin communication with the GPS at the same baud rate. GPS baud. It was already mentioned here. GPS baud equals to 9600. So GPS port dot begin GPS baud. GPS baud is a constant. So its value is 9600. Okay. Next is bolt IoT dot begin serial. What is serial? Serial has started communication at 9600 rate. If you put serial over here, bolt IoT will also begin communication at the same rate. If you remember properly, we had used the same baud rate in the Python program as well. So you have to use the same baud rate. Okay. Apart from that, what will be the other initializations? The buzzer should be set as output. Buzzer is an output device. So set it as an output. Okay. The status LED or the enable LED should be an output device. Okay. Now the enable pin. Now, if you remember clearly, the enable pin has been connected to another pin on the Bolt IoT Bolt Wi-Fi module. It hasn't been connected into a sensor. So if you do not connect it to a sensor and if you connect it to a pin, what happens is the pin normally toggles between a 0 and 1 state. It keeps on toggling. There is no static state for the pin. So in order to prevent that, we have to set that as an input pull-up type. What is an input pull-up type? When we set it as an input pull-up type, it will remain at a static state. So firstly, we will set the enable pin as input. Okay. Why is it an input? We will receive input into it. From the Bolt IoT module, the status will come into the uh, Arduino module. So that enable pin will basically be an input pin. So first set it as an input, then digital write high onto it. Why high? Input pull-up will only work if the normal state or the ground state or the usual state of the pin is 1. You cannot set an input pull-up to 0. It has to be 1 at the normal state. And this is the very reason we have used enable as 0 and disable as 1. In normal conditions, security will be disabled. So when you keep the security disabled, it has to be in such a state that it corresponds to the input pull-up. So input pull-up works with the normal state of 1. So that is why we have used disable as 1 and we have used enable as 0. So after you set enable to high, then you can convert it to input pull-up. So you just convert it to pin mode enable input pull-up. Next comes the loop. Okay. Inside the loop, what will you do? You will read sensor readings. From which sensor? From the LDR. So as you will remember, the LDR is facing the laser. So it's getting some reading. So you will continuously read the sensor, the LDR. Now, after reading the sensor, if x equal to 0, if x equal to 0 means the x is actually the digital read of enable. First, you have to read whether the user has enabled the system or not. If the user has kept the system disabled, there is no need to read the LDR. So first, just read whether the user has enabled the system or not. So you are reading the enable pin. Now, if x equal to 0, as I told you, 0 means enable. So if x equal to 0 means user has clicked on enable. So we'll discuss the enable later. Let us discuss the disabled portion first. So this is the else portion, which is at the bottom. If x is not 0, that means x is 1. X can either be 0 or 1. So if x is 1, what will happen? X is 1 means the user has disabled the system. The system is not on. That means the security is not required now. So if the security is not required now, that means maybe you are using the car, maybe you are driving the vehicle, so you do not require the security right now. So you set stolen to 0. That means your car has not been stolen. You are using the car. Okay. Set the buzzer to low. The buzzer shouldn't be sounding. So set the buzzer to low and set the status LED to low as well. So if you have set the status LED to low, that means the system is disabled. Now, if it's enabled, which is x equal to 0, what will you do? First, you will set the status LED to high. Okay. Next, you will read the what will you do? You will have to read the LDR. Now, why we have put the laser facing the LDR, I'll discuss in the next slide. Just remember, if the LDR is facing the laser, it will give a certain value. If it moves away from the laser, it will give another set of value. So that is what we are doing. We are seeing if the LDR has moved away from the laser, which is a value greater than 100, or if stolen equal to 1. Why is stolen equal to 1? I'll tell you later. Just remember if value greater than 100. So if value greater than 100, this corresponds to your vehicle has been stolen. So you set stolen to 1. It was 0 previously, set stolen to 1, sound the buzzer, digital write buzzer of high, and search for whether the GPS module is present in the port, read the port, fix is equal to gps.read, and every 10 seconds, see plus fix count greater than equal to 10. That means it's counting to 10. Every 10 seconds, print the latitude information to the serial port and longitude information to the serial port. Again, set fix count to 0. Means again it will start counting from 0 to 10 in the next part. Okay. Now, after you are done, again the loop will run. When the loop runs, once the vehicle has been stolen, you just have, in the next iteration, you just have to see if val is greater than 100. Val is greater than 100 means whether the LDR has moved away from the laser. Now the LDR has been fitted in such a way that it's fit on the door of the car. That will be discussed in the next slide. You will see. So once the person opens the door, or the thief opens the door or breaks it, the LDR will move away from the laser. Again, when he pulls the door towards itself and closes it, the LDR will again come back. So next time the value will not be greater than 100. Again, the laser will be facing the LDR. But now your vehicle has been stolen, so you are getting stolen equal to 1. So the buzzer is still sounding. Again, it is retrieving the latitude and longitude value. Again, it is sending. So this keeps on happening. Okay. Now working of the system. This is the last part. Now, if this is the card and this is the door and this is the frame, it has been zoomed and shown. The LDR is fitted in on the door of the car inside the frame of inside the frame of the door of the car, and the laser is fitted on the body of the car inside the frame. So basically, when you open the door, the LDR opens with it, and it gets moved away from the laser. And again, when you close it, it faces the laser. So that is what was happening in the Arduino code. It was just checking whether it is facing the laser or not to determine whether the car has been stolen or not. Okay. Now, first the user has to enable the system. So when he enables the system, the status LED starts glowing. Now, when the thief wants to steal the car, he breaks the door open. When the door opens, the LDR stops facing the laser for a moment. So that triggers an alarm, and that triggers the action of sending a message or notification to your phone. And this is done every 10 seconds. Even after you close the door or the thief closes the door, since stolen variable has become 1 now, it still signals that the car is stolen and the process continues. Now, this is the page of the Telegram channel, which is showing the message being shown, sent. Your car is being stolen. Current location of the car is as follows. This is the Google Maps link. So you just click on it and you can know the location of the car. This is done every 10 seconds. Okay, next. When you are done with the process, just click on disable. The LED will be disabled and the buzzer will stop, as well as stolen will be set to 0. So when stolen is set to 0, that means your card is safe now. Okay, so when you don't need it, just disable the system. Your card is safe now. Okay, so this is a working video of this. Okay, so this is the entire setup. This is the Bolt IoT Wi-Fi module. This is the Arduino board. GPS, the LDR, laser, buzzer, and the LED. Okay, so this is the script running on the server side. This is the script gps.py running on the server side. Okay, see the LDR is facing the laser. This is the laser, this is the LDR. LDR is facing the laser. Okay, see. Now, when it is disabled, when you move this thing, when you move the LDR, open the door, it opens with it and closes with it, and nothing as such happens. Status LED is off means it's disabled. Now, when we want to enable it, we'll use the mobile application. This is the mobile application. We click on enable, the status LED starts glowing. When we disable it, it switches off. When it's off, nothing as such happens. When it's on and the thief tries to open the door, it removes it and the buzzer starts sounding. There's some problem with the video's audio, I don't know what, but there should be a you should see the notification being received on the phone. Just wait for it. Takes 10 seconds. Here, see, this is the notification. We can just click on the Google Maps link to know the location. See, it's showing the location. So this is done every 10 seconds. When we are done with it, we can just disable the system. The system gets disabled. The status LED is off. Okay, that's all. So now you can pose your questions. Anyone who wants to pose your question is open to do so.